Hello, my name is Garrett and I will be showcasing my isometric terrain generator and visualizer made in Python using the OpenSimplex and Pygame libraries. The first thing I created was the visualizer, so I could actually view the progress of the terrain generator. The first thing I needed was a formula to project 3D coordinates into 2D isometric ones. I found this formula online, which can be simplified for our purposes by getting rid of the trig functions in favor of a 2:1 ratio of width to height, and of course adding an offset to center the projection. We can use this using a simple function with the inputs of the x and y world coordinates, and it looks something like this. I'm drawing the result as lines using the Pygame library. The red isn't a very appealing color, so I created a function to match the z coordinate with a color, which makes it look a little bit more appealing. However, I was unhappy with the result. I then learned about Matplotlib's color maps, which happen to include a terrain one. I think this looks a lot better. I also added the ability to scroll through the terrain using the arrow keys on the keyboard. The next thing I wanted to add was shadows on the terrain to really sell the pseudo 3D effect. The way I did this was actually really simple. If we imagine the sun at a 45-degree angle looking directly at the side of the terrain, we can check at every line if there is a line in front of it that satisfies this condition. In the case that it does, we divide the color by 3, simulating a shadow. The only problem with this system is you can't change the direction of the light. This does make it look a lot better than before, however it does come at the cost of a huge performance hurdle. Now Python is naturally a slow language due to its interpreter, but it shouldn't be running this poorly. To see why that is, we can imagine the display as a canvas. Right now I'm using what's called the painter's algorithm, which is where you draw everything from the back to the front, much like how a painter would paint. This does ensure that the things in the front are visible, however we do draw a lot of unnecessary lines that are just going to be drawn over anyways. To fix this, we can create a Y buffer which stores the height of the highest point at every X position on the screen. We then change the loop to render front to back rather than back to front, and only draw that X coordinate if the Y value is greater than the value in the Y buffer. I also changed the width of the lines. This improved the performance a pretty fair amount. Now it's time to start working on the terrain generator. There are a few options, including both Perlin and Simplex noise. I chose Simplex for the reason that its sample function was able to be vectorized by NumPy so it wouldn't drain the performance as much. The library I'm using for the noise is OpenSimplex. Simplex noise on its own doesn't look very nice as terrain, but if we layer multiple noise functions at differing amplitudes and frequencies, we can create more intricate details. This, however, creates the new problem of the terrain being too leveled. To fix this, I thought it might be a good idea to use a sigmoid function on every point to make the terrain more jagged with higher peaks and lower valleys. This creates a pretty interesting looking terrain which I'm pretty happy with. Unfortunately, there is still a large performance issue that I wasn't able to resolve. Now of course I could have used Numba to compile the render functions, but that would require an entire rework of the methods and the classes used by the function to be compatible with C typing. And at this point I was already running out of time, so I left it as is. I hope you enjoyed the project as much as I did making it.